Okay, audio check. 1, 2, 3. All right, I am live. Oh, good heavens! I was up too late last night, but we are here. We are gonna get started. I am the Discourager of Hesitancy. Welcome to my stream. We are developing a game from scratch with no engine and only 4 dependencies, or 5, depending on how you want to slice it. Minimal dependencies, write everything else ourselves. We are in the final stages. Hey, Dravest. We're making what I call doodads, little interactable pieces that have nothing to do with the main gameplay, so that people have something to fidget with. I always like that in Hearthstone, all the things you can click in the Hearthstone environment. So we're doing something like that. We made a little solar system yesterday. I don't think we'll add asteroids, but we'll probably add a nebula. I don't see any reason not to have some nebula, or a nebula, or something. And then what? Well, more stars. It needs more stars. Then we will see what's left. We'll see how much time we have left. Art always takes me a long time. Like yesterday, the solar system, getting that up and running only took me about an hour. Drawing the planets took me 3 or 4 hours almost. And they still need some work, so what do you do? But art doesn't have to happen on the stream, so the cleanup artwork I'll do off stream. But we'll do some art today. So how are you doing, Dravest? Okay. So, what we did. Oh. We are going to change this. Gonna do a quick little rebuild. And yeah, so this should finish up the space doodad today. We'll take a look at it and decide what we want to do from here. Artwork needs cleanup. We'll do that off stream on my own time. Nobody's paying to watch me do art. Let's just see where we're at. We'll do some art, but clean up, tidy up work. Not interesting. So we have a solar system. We have some stars. I'm actually a little surprised at how the stars don't show up very well. So we have to add more stars, bigger stars. These revolution times are not the final. We just made them fast for while we're doing the development. Yeah, so we're gonna add more stars. I do want some little twinkly stars, I think. Doing good. Been implementing CSS design today. Going to do some JavaScript testing. Nice. Always good to get the CSS done and move to JavaScript. Cool. Okay, so let me think here. I guess we jump over to GIMP. Where's my GIMP button? Oh, I saw it. The scroll's not very good. Here we go. Let's swing GIMP. The problem is the teeny tiny little stars are too teeny tiny. So it looks okay on the screen. It doesn't look as good on the chalkboard. So we're going to make some bigger stars. 6. Also, they have to kind of scale with the with the screen size. So add some more big ones to this diagonal. We want like a band here. Then we'll add some more in other places. I tend to put bigger stars towards the bottom, I think. Okay, then 4, I think these ones showed up okay at the current size. These little tiny ones don't show very well. So we'll just add some more of these big ones. If you ever look up at the sky in like a low lighting situation, it's actually pretty impressive just how many stars there are. Like it's kind of fuzzy in places even. I think some of these 2-pixel ones show up okay. So just add more of those, lots and lots of them, especially along this little band. Skies are not uniform density. So even zoomed out pretty far, it's not too bad. Just add a few more here and there. Okay, save, export. We'll try that. We'll see if that looks a little better. We're gonna add, oh shoot, made to not do that. I exported it with a background in file. Re-export, rerun this. Okay. And then I do want some like active twinkly stars, maybe like 6 or 8 of them. I don't know if I want to do, I guess they would be sprite animations, wouldn't they? They wouldn't have to be very big. Okay, so that's done. Do a bit of a rebuild. Okay, so make some little twinkly lights. I do want some kind of nebula. I don't know what that's going to look like yet. The star field is about the height we want to occupy. I don't know, maybe we put the we can overlay the nebula in the star field. It's not that bad. But here we go. So yeah, we're going to finish up the space one today. And tomorrow, or next week, we will wrap up the last chalk doodad. We'll do a little plant growing one. You know, schoolroom, chalkboard, bookshelf. Learning about biology might be good. Biology, space, history, that's our archer. I guess the ball and the bubbles are more about physics. Trying to justify them, right? But yep, we're close to done. Close to done. So we're gonna wrap up all that. We're gonna wrap up those last two doodads. We're gonna add a mechanism to switch between doodads to end one or start a new one for the chalkboard at least. And then what? We have to optimize for space. We have not done any data compression yet. That will be coming up. Okay, that looks better already. Like I said, other than the artwork needing to be tidied up. I don't feel like these stars extend all the way. What the heck? I thought we measured this. The stars don't go all the way. Okay, well, we can fix that. Starfield. Set bounds. We're going to get a width and a height. We can actually rescale our star field to our boundary width and height. So our new width, so rectangle.width over star field current width is the ratio to compute a new star field height. The height times this ratio set rectangle 0 finds our star field height. We'll take the full width of our boundaries and then take our star field height. Let's try that. Does that stretch it all out to fit the area we need? Oh, right. Okay. So I figure I've got one more week of doodad work left. Okay, now the stars extend the full range. That's even, that's fine. Stars don't cause me any issues yet. Okay, that's all very calm and relaxed. Okay, so better stars, definitely better. I guess we should. We're not doing asteroids. We did not do a nebula. Static stars. Okay. That's done. So for today, I do want a nebula. Dynamic stars. Sprites. Maybe add a comet. I don't know if I want to comment. I don't think I do. Set some sprites that twinkle. Nebula, and then the piece that I actually want to build. Special. Interactable. We'll add that in. Right now it's not very interactable, it's just moving stuff. Okay. The nebula is going to be very static as well. In fact, it's probably going to be part of the static star field by the time we're done with it. You know what? Doesn't NASA just have pictures of nebula? NASA nebula pictures. NSS DCA photo gallery nebulae. There we go. Maybe we'll take a look at some of these. Boom. These pictures were taken with the Hubble Space Telescope provided. All images are blah, 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 blah. I'm trying to Arnessa nebula pictures, public domain. I'm pretty sure they are, but it'd be nice if it was confirmed. Guidelines for using NASA images. Generally are not subject to copyright in the United States. Yes, for educational information, computer graphical simulations, blah, blah. News outlets, text authors may use NASA content. What about for commercial use? Commercial use. In books, clearances may be necessary for images that include any NASA logos. Media. Non-fungible tokens, AI. Good heavens. Well, NASA has a ton of stuff. I don't want to use the logo. I want to use your pictures of space. Anyway, maybe we'll just chalkify it, and then it's our own original work derivative. But the Hubble Space Telescope was paid for by tax dollars. I think that means that anything taken by Hubble is public domain. Hubble Telescope images domain. So we go to the Hubble site. All material was produced by NASA. Produced, was created, authored, prepared for NASA under contract. Otherwise, specifically, no claim to copyright is being asserted. It's freely used in the public domain. Okay. So I don't know. Maybe we just grab some. Maybe that's the easiest thing to do. But we're doing dynamic stars. So the attention's very short attention span today. Okay. I've got that link saved in the chat. We can always come back to it. Let's go back to GIMP. I think we just want some very small very small, actually. In fact, I might be able to fit multiple things here. So that's 1920 from 2048. Yeah, that's plenty of room for multiple star twinkle animations. Okay. So 1920. Let's give ourselves a nice 16 pixel rectangle to work with. So there's 36 plus 16 would be 40, 52. So there's 2 star animations. We could potentially have 52 plus 16 puts us at 68. 78 plus 6 would be 84. 84 plus 16 is 9100, so 2000. 2, 3, 4, 5. 2016. 2032. There we go. 1, 2, 3, 4, 5, 6, 7, 8. 8 different sprites. 16. 32. 48. 64. 80. 96. 112. 3, 4, 5, 6, 7, 8. We'll just have to be careful not to put any pixels in the outer pixel range here. Actually, I can think of it. Okay, I know what that one was for. Where are we? 112, 28, 30, 44, 160, 76, 82, 92, 92, 208, 224, 240, 256. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We can put a 16 frame animation in 8 different slots. So we can have 8 twinkly stars that are all different. And luckily, twinkly stars, I think, are easier to animate than stick figures. This is my operating theory. Elpsy Kangaroo. Oh, we're making the galaxy doodad. Yes. Actually, we've got the galaxy doodad partly done. The animations all work. This artwork needs to be cleaned up, but I'll do that off stream. I've got a static star field. We're going to make some little animated star twinkles. just for fun. Yes. We're going to do that. We may steal some NASA art for Nebula. It might be easier that way. But yeah, we're having fun here. We're having fun. So, twinkly stars. The current thought is let's make a new layer called star. Let's see, twinkle star sprites. And we are going to crop it to this area. And we don't actually want twinkle stars to export UVs, so we'll have that separate. Okay, twinkle stars, here we go. We got a paintbrush. Paintbrush white, grunge 2, opacity 100. Oh, it's under black. There we go. Oops, it daisy. We've got 16 frames. We're just gonna throw that all together. Cool, looks like it's coming along. Yeah, slowly but surely. These projects, especially towards the end when you're can kind of drag a little bit, but it'll be great. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, make sure I'm counting right here. Okay. It also has to shrink, so we need to hit peak size. 1, 2, 3, 4, 5, 6. Now it's going to be 1 pixel away from the edge. So on screen it's going to be small, but that's okay. We can add a rotation, that would help it look a little bit more dynamic. 1, 2, 3, 4, 5, 6, 7, 8. Um, those little offshoot sparks to be fading. We're just gonna make one real quick. Let's just see how it looks. See if it's worth pursuing. Center should always be right. This is more like a nova, I guess. Okay. Okay, so there's our first star animation. Like I said, we'll give it a little rotation. It won't be long on the screen. Maybe we'll even add some alpha to it. We'll see. Okay, so we're going to export to the PNG. We're just going to play with it for a minute and see if we can make it look better. Or see how it looks at all. Let's see here. OBS to turn off GIMP. There we go. Images. We have a UV sprite called Twinkle 1. I guess it'll play at 16 frames per second, so it's a 1 second star. It doesn't loop. Size of 16 by 16. Offset X0. The y-axis offset we did measure, that was at 1920, I believe. 1920. There was no spacing. Range from 0 to 15. Twinkle 1. Okay, embed our data. Oh shoot. I have to turn off the black background. I have to redo this. Just the background and yeah, we already missed it. One more time. Okay, while it's doing that, face needs a twinkle star. Sprite. Twinkle 1. We'll just get for now, that's fine. Okay. Fade in. None of the twinkles happen during fade. Update. Update. Update twinkles. We'll make it a whole separate function. Render. We're just going to keep this pretty simple. If m underscore twinkle1 that is running update. Otherwise, we're going to start a new twinkle. And for starters, it's not going to be that complicated. M underscore. I guess the initialization needs a little work here. We'll break this out if we need to later. M underscore twinkle1 set texture. Same as everybody else, we're all in the same image. Twinkle1 dot set. Oh, let's see here. Virtue. Set Robert state. Set sequence, that's what it's called. Image warehouse. Animation sequence. Sprite animation key. And that is twinkle. Otherwise, underscore twinkle1 dot reset underscore twinkle1 dot start. And then we want to pick a location. We need some of this as well. Sprite animation key twinkle1. Oh, come on. Let's see here. Think of this. Except for twinkle1. Get our width height, scale it to the screen. Twinkle1 dot set rectangle 0, 0 width and height. Twinkle1 dot move to starfield dot x. Starfield rect. I have a function for this already. Rectangle dot h. There's middle y. So we're just going to move it somewhere, do a reset, and start the loop again until it's done. Which might not look very good for starters, but that's where we always begin. Okay, well, that's definitely not right. Should do it tidy and debug. Okay, well, what has happened here. All right, maybe I should actually look at the thing here. Something bizarre is happening with my image warehouse. And of course, it's imported everywhere, so. What's going on with my image warehouse? The CPP should be safe enough to load. First error happens here. Twinkle 1 equals 0. What? Why does this not have a comma? If we put a comma in, it probably fixes everything, but this is not the output I would expect. So where is twinkle? Yeah, that's all correct. Huh. Sprite animation key. Twinkle 1 equals 0. But why is it not? It should have the file name prefix like above this, and it should have a comma there. Options. Put Robert at the top. I don't like that being a workaround. Not at all. Twinkle. For whatever reason, Twinkle is not getting a comma like everything else we've got here. Okay, well, clearly we have to fix that. Find the number of sprites in our image. If UV index for our image UV index equals 0. UV index. Oh. Okay. If sprite key index equals 0, sprite key index is equal to that. I think that's better. Build target equals and then PMGs. Right key index. Sure, that can be uint, it doesn't matter. How is plus plus not defined? Because it's inside of another expression. All right, I'm gonna redo this, re-embed everything. Then we'll look. Gonna head out. Hope it's a good stream. Yep, it'll be great. Check in later. Awesome. We'll see you then. Good luck on yours. Okay, then tiny debug. All right. So basically, every time a star stops shining, it'll go twinkle itself in some random location. We will add maybe rotations. Alpha or scaling variation, maybe. I don't know. We'll play around with it. Okay. All right. That's better. Space. We need sprite. So fix twinkle 1. Update twinkles. You know what that's about? That is dot texture quad set texture. Okay. I expect the star to twinkle. Oh, that's not bad. Yeah, I've seen worse. Yeah, we exported everything with the black background instead of alpha. So that's embarrassing. Okay, we need some variety. Variety. I can think of 1, 2, 2 factors. So one thing we want is a delay before the twinkle starts. We want to choose a random location. So we want the star field rectangle. Okay. Oh, set clipping entity. Twinkle 1. Quad. Set. No. Texture quad. Set clipping entity. There we go. Move to some random location where we take m underscore map URNG r dot width float r dot height reset and start. One. That's a position. 2. We kind of want to randomize the duration of the stars. We don't want them all to twinkle at the same rate. Yes. Like a plus or minus 25%. Image warehouse. Get sprite animation FPS. Get sprite animation length. integer of FPS minus math URNG. Next, float between 0.75 and 1.25. So if our FPS is 16, which it is, 16 down to 12 as high as 20. Can we do that? Let's see, just float of FPS. This is our period times our length. Length over pips. This is how much real time it's going to take. And we can do between 0 and 1 rotations. There were 2 rotations, why not? We just call it twinkle spin. Like, there are other ways we could do this. We have tools for animating the rotations. I don't know if we want to do that necessarily. Look, rotational velocity is twinkle 1 rotational velocity equals. We're going to do this many rotations over this much time. So it's rotations per duration times 2 pi. Twinkle 1 dot rotate by this time. Actually, you have delta time already? dt. We do. Just pass that. Twinkle 1 dot rotate by m_twinkle 1 rotational velocity times delta time. Update. I mean, we could even pick a velocity and have our star travel while it's twinkling. I don't know if we want to do that. Let's just see how far we get with this. Set fips, reset, start the animation, move to a random location. Which I think we will forego for a minute while we look at other things like rotation. I want to move to r.x plus 100. r dot middle y coordinate, just so that we can see the different random effects before they get moved all over. Oh, I do need to redo that. Hold on, just a second. Save, export. We do need to re-embed that because I did it wrong. I had that black background visible. Okay. Okay. If we get one little star, it's easy to make it a bunch of stars that twinkle. Oh shoot. I'm just going to restart the debug. Build. Okay. And while that is going, I'm going to unwrap one of my alfajores. Tasty little treat from Argentina. I had a friend get some across the border to me. They are kind of expensive by the time they're shipped here. I had inside contact. Very nice person. I finished off the white chocolate ones. I'm on the plain ones. I'm saving the chocolate dipped ones for last. Those are the good ones. Those are the best. Okay. One little twinkle star. We'll also probably set a random alpha value. So it looks like there's different depth. Maybe we'll even scale the size. Like basically as much variation as we add to the twinkle star in random generation, the more different the sprites themselves can be and still look okay. Or something like that. So we give like small variation in color. Stars do tend to be red shifted. We're just exploring ideas here. That's just rude. Set frames per second, of course. Another thing we want to do, twinkle one dot set use scaled time to default. So we want this to be real time. Okay. So if we get this one working, we'll spin up 8 of them. Once we get this one tuned the way we like. Okay, the star will be right in here. There is a crash. Close. Move to so if we had one rotation in 1 second, that would be 2 pi per second. Rotate by 2 pi per second times the amount of time. Duration. Our length in frames, our frame count. So I have 16 frames over 16 frames per second. That would be a duration of 1. Frames per second. Sixteen frames over 8 frames per second would be a 2-second animation. Maybe the parentheses. It might have been doing divide length by fips, getting 0. I mean, it should have been 1, but then when we cast that to float, the duration was 0, which would cause this to blow up into a not a number. Maybe? Maybe that's what's going on here. Invalid math. I can never remember the precedence order of all the things. I do tend to put more parentheses around things than strictly necessary. Unless it's like basic arithmetic order of operations, I don't really want to keep track of it. There it is. Pips and length. Right, count a new pips. Duration. Rotations. And our rotational velocity. Or if we log things, it'll tell us what's wrong. Ooh, wow. 1.5 revolutions in 1.6 seconds. Yeah, my rotational velocity is 6. Two revolutions in 1 second. That's 2 pi. Okay, so that does make sense. These numbers make sense. This I'm okay with. This I'm okay with. What if we don't do that? We don't do that. We'll put one in and then we'll put the other one in. See which one's breaking. I know DT's not being used. It's okay. It will be soon. Okay, there's our twinkle star. Very cute. What if we change the brightness per second? Is that what's breaking me? I don't think I've done that a lot. So maybe that's just an exercise part of code that is not updating the period correctly. So we have twinkles at different rates. We can see that. So something about the rotation then. Rotate by. But we've used rotate by before. And rotational velocity is fine. We calculated that. That's in fact. Math. URNG .2 coin toss. We just negate it. Underscore twinkle. See. Just a moment. Okay. All right. So it's rotate by. Is that our issue? Oh, coin flip. Sometimes it's positive, sometimes it's negative. There's no reason everything has to rotate in the universe the same direction. But that angle I think it looks valid to me at 6 radians. Oh, that's in Root. Rotate to and by oh, those are in radians. Angle, is that what I called it? Yeah. Angle plus revolutions times that. Shouldn't have to, but if that's my issue. Oh, well, we don't even need to rotate the sprite. There it is, it's rotating now. Oh, cute. Okay. I guess that's it. I don't know why rotate by wasn't working. But okay. Okay, we have positions. Another thing we might want to do is then underscore twinkle1 dot color. Your quad. Twinkle1 dot texture quad color c dot alpha equals math dot urng next integer from 128 to 255 underscore twinkle dot texture quad set color. See. So they'll be more or less visible. Right, frames per second, rotation. We could also scale the size a little bit. So basically this code here moves down into here where we set our position. So we get our size. The size of our frame. Because later on we're going to break all of our different twinkles up into like an array or something. We're going to set our rectangle to this. Might as well take away this part. Put y equals a thing. Set rectangle x, y. Set center. Move to, yeah, so this is basically float x equals this, commented out, deleted. Except we're going to scale float width and height. Float scale equals URNG next float, and it will be some amount. .5, 1.5. So scale times width, scale times height, scale, and scale. So the size of them will change, the alpha will change. W is not declared. I agree. Aren't we doing next float in places? Oh. Oops. Okay, then we'll set random positions once we verify that size and alpha vary. Could have the star move a little bit. I don't know if I want to do that though. I think it's fine if the star just twinkles where it is. So here's our star. The position is changing. Roughly scaled with this size. Okay. Still, that's plenty of variety in a single star. I'm pleased with that. 0, 0, twinkle 1. Set move to X, Y. I shouldn't have to do that. X, Y. We're going to center, then set the rectangle. Is that center my star where I want it? Or do I have to do the game I just was contemplating, where I set the rectangle 0, 0, and then move 2 after setting the center? Unclear. We don't want these stars to just all pop up at once, so I think a time delay is going to be important. Yeah, different sizes, different alphas. Even though that's just one sprite animation, that's quite a decent amount of variety. Cool. I think we are rendering that on top of things it shouldn't be. So render. It should render on top of the star field, but behind the planets. Rule number 1. Number 2, let's go ahead and move it around. Last piece. I think we do want random weight between star twinkles. So each twinkle needs a timer. Like I said, we'll throw together 8 twinkles. Whoa. That twinkle is showing up all over the place, but in the wrong half. So I need to add this y coordinate. That makes sense. Y, the rectangular height, Actually, r dot height plus r dot y. There we go. Okay, then we'll make like 8 of them. Oh, we need a delay. We need to add the delay. Oh, yeah, very good. Okay, there's our twinkle star showing up all over the place. Okay. That is a twinkle star. We need 8 twinkle stars. We need the delay. I need the delay first. Chalk space. Header file. So we have twinkle 1, twinkle rotational velocity, and an egg timer m underscore twinkle 1 delay. Okay, are we ready? Here's what's going to happen. M underscore twinkle delay. Let's see. M underscore twinkle 1 delay. Set single shot true. Twinkle 1 delay dot set. I forget what I called it. I don't remember if I called it ding or like set ding or just set callback. Set callback. Set callback. Okay, set callback. The other thing we want is set use scaled time false. Set single shot, and on the callback we do the following. This m underscore twinkle 1 dot start. And that is it. Now over here, m underscore twinkle 1 delay set duration math urng next float. We can wait anywhere from 1 to 5 seconds. Start. M underscore twinkle 1 delay I think we can just do that. Okay, we get our new position. We get a small amount of scaling, we get a small amount of color control, we get a random duration and rotation. This is just reset ourselves, then we prepare a random weight, and then we start the timer. This timer updates, and when it's done, it starts the twinkle 1. If it's running, it updates and does things. Delay dot is running. So if the timer is not running, the timer should be done before we start. There we go. We'll try that. We don't need to embed our visuals yet. Okay. pretty soon we will have many, many twinkly, twinkly stars. Like 8 of them. Progress feels good. 1.140. Yeah, we should have stars done by 2 o'clock. 40 more minutes. 2 hours worth of dynamic stars. Well, I have to animate 7 more star sequences that look sufficiently different to be interesting. So we'll see how that goes, I guess. We could make them colored. I don't know if I want to color them out. Yeah, we'll see. Oh, assertion failed. Oh. Egg timer is already running. Oh. Space. Twinkle 1 delay update. It's running. Update. If it's not running, bottom of this, oh, one more bracket. Else. Confusion. Oh, did not put braces. Okay. Let's see, said the blind man. If the timer's running, we don't do anything. If Twinkle is running, we just update it. Otherwise, we set everything else up for the next cycle. Let's do a full clean. Whenever the word yes comes out wrong, I'm a little suspicious of my memory. Suki, welcome, welcome. How are you doing? We're gonna be here for a minute with this build. Oh, great. Me? Oh, I'm doing pretty good. I think we'll have some nice twinkly stars here. And then I decide if I want to do nova, like a nebula or not. We might just steal the nebula from the Hubble Space Telescope pictures. I heard something really bad that happened. Oh, what's that? What happened? What's bad? Apparently town got fined $10,000 for not celebrating Pride Month. Huh. That's rather odd. How can you get punished for not celebrating something? Like, you can't even get in trouble for not celebrating a federal holiday, and Pride Month is not a federal holiday, and the fact that it's a month is ridiculous. And then some of the nonsense that happens on those days should be frankly illegal. course, I've also heard of people laying down rubber on a Pride sidewalk or a Pride road painting and getting in trouble for that. Human Rights Court. Oh, well, I don't think the Human Rights Court actually has any authority to enforce their fine, do they? Human Rights Court? I'm not sure what authority they have to enforce. I don't care about the European Court of Human Rights. Oh, although that also could be where this, I don't know, is this in the United States? Huh. Well, that seems silly. I have never once thought that somebody should get in trouble for not celebrating my religious holidays, so I should not be required to celebrate anybody else's religious holidays. Let me see. Canadian town, here it is. A town in Canada for refusing or fly the flag at its municipal building. Huh. And the officials are required to take mandatory human rights training. Are they not going to tell me what town? Oh, the town of Emo, Ontario. That makes more sense since this is Canada. Their main argument was basically like this: why aren't we celebrating straight people then? Yeah, I don't have a flag. Where's my flag? Oh, it's ridiculous. There are some strange people in the world. I think people should just leave each other alone. Leave me alone, I'll leave you alone. That's my life philosophy, I guess. Now, that being said, legally, that's not a very good argument. On either side, though, bringing the case was not legally sound. But if their defense was there's no celebration of straight people, that's also not a good legal defense. It should be based on freedom. Well, and it's in Canada, so maybe you don't have the same sets of rights. In fact, I know that some of the rights in the United States Constitution do not exist in Canada. But in the United States, we have freedom of association, freedom of speech. You cannot compel speech, and you can't force me to participate in things I don't want to participate in. So those would be far stronger grounds. But it is Canada. I don't think Canada has the equivalent of the United States First Amendment. If I remember right, the United States Constitution is the only one that guarantees freedom of speech, religion, association in the First Amendment. I don't think freedom of expression, Section 2 of the Canadian Charter for Rights and Freedoms. That, I think, would be a far stronger basis for refusing to participate. However, in practice, the Charter permits the government to enforce reasonable limits of censoring speech, such as hate speech, which has no legal definition, obscenity, and defamation. Yeah. For example, you should not be exposing children to obscenity. That seems reasonable to me. Hate speech has no clear definition in legal terms that is not subjective and therefore legally not enforceable in any meaningful way. Defamation makes sense. Yep, those will make sense. One other is inciting illegal activity. Should also be not protected. But hate speech means nothing. In fact, even Wikipedia agrees with me. Hate speech is a term with varied meaning and has no single consistent definition. Therefore, it's not legally enforceable. So yeah, no, they would have been far better to not do the we don't celebrate straight people to going to the Section 2 of the Canadian Charter of Rights and Freedoms. That probably would have been their better option, legally speaking. Oh well, Life's rough. What's funny is these are all the same people who, what, 20 years ago were all upset at how the right was trying to um, enforce obscenity laws on television and compelled, not compelled speech even. They never went that far, but you shouldn't say those naughty things on the radio. That's just shameful. And now they're doing the same thing, but just the other way around. Ridiculous. But you are Quebecois, right? So Montreal, that doesn't affect you, right? Although I don't know, is Quebec more or less on that side? I don't know the political landscape of Canada very well. Okay, fresh build. Let's see what we got. Okay. There are twinkly stars. He does appear from time to time. Okay. Let's make eight twinkly stars. Moving it all to an array. Number of twinkles equals 8. Number of objects is 1. Num twinkles. So the +1 is for the star field. A twinkle, num twinkles. Oh. Yeah, they don't even have an official flagpole. That's funny. There's also the second reason they decided to find the 10,000. I have some teachers that swears a lot. Yep. One of them was in a stage for being a French teacher. Told the student to F you. Nice. But also she didn't really care because it was the last day she was teaching. Oh yeah. I mean, there's no penalties they can reasonably enforce on your last day of teaching. So, yep. What a strange world we live in. Strange world. So, twinkle 1. I guess we should do init twinkles. Twinkles delayed, twinkles thing. Okay. Okay. So let's then do that chalk space num twinkles. Okay, texture, not sprite. Equals. There we go. Twinkle, oops, I don't want to do that. Twinkle 0.2, there we go. Big timer start, timer equals. Okay, so that gets all the twinkles. And then, everywhere where we see this, we get our index here. Wrap it all up inside of that. So firstly we need the timer. We need the sprite. That only matters in here, basically. All right. Timer. And everywhere this thing is. Oops. Equal 2. Okay. Also, when I was in English class, we had a whole speech on why we shouldn't use the word autistic as a slur. The thing is, it actually did the reverse effect of what she expected. Yeah. Well, first thing you do is you tell kids, hey, this is a word that's very offensive. You shouldn't use it. They're like, oh, great. A new insult to throw into my arsenal. You're saying that autistic is offensive? Perfect. Then I'll use it. This is the rare case where it was better for her to just shut up. Yeah. Yeah. Yeah, what is this called? The it's like the Streisand effect, right? You tell people don't look over here. What does that cause them to do? It causes them to look over there. Oh boy. Yep. Underscore twinkles rotational velocity sub index. That seems good. Okay, so we should. Oh, the other thing we need to do, where we init twinkles, add child twinkle. See what we're building. Okay. Hang up and debug. Here we go. Yeah, the worst thing is she actually gave a good reason to use that as a slur accidentally. It's amazing to me sometimes how many adults forgot what it was like to be a kid or a teenager. They're so self-righteous and preachy. It does not. Time to ban someone. I don't know. Only one so far today. There are some days it's a little bit ridiculous. I wouldn't mind so much if they like hung around and watched the stream and at least boosted my numbers, but it literally pop in for 3 seconds, paste, and go. If it was a bigger problem, I'd waste more time on it, but let's see, where's the click to reply? I wonder what would happen if I just trolled them, just like, hey, how do you know if they're the best viewers? By what metrics? Who's verifying this? How many? I don't know. We did goof that up. 0.2 dot. Equal 1 is not a thing. Oh, I guess that makes sense. So we need that for loop. Twinkle subindex. Render. Oh, that's just part of initializing these. All right. I think just the domain is sketchy. Hey, you can't be racist against Russian. Actually, no, you can. That's totally fine. Everybody's racist against the Russians. It's their fault for being descendants of Vikings. Just buying a .com domain would have made it look less of a scam. So SFML, I'm curious. Why do you not like it? I don't know anything about it. This is the first I've heard of it. So what's the story? What's the deal? Qualified ID and declarations before. Slightly confused. Oh, there we go. Loose brackets, always bad. Okay. And it twinkles. Oh. Actually, we can just pass just the twinkle. And done. Even better. Because it gives me seg faults each time I use their text library, even if I copy and paste their own code. Oh yeah, seg faults, always fun. And when it's in someone else's library where it crashes, it's harder to debug. But then it often turns out, not always, but often turns out that the problem was something I had done before. But there's no functional, no meaningful way of walking backwards through your code other than in your head, which is tedious and painful sometimes. All right, there should be 8 twinkle stars popping in and out of existence from time to time. Oh, how cute. Do I even need to do more animations? I mean, we still will, I think, but... Alright, not bad. Not bad. We can do a couple more just to try it out. Yeah, it took me a while to get free type running correctly, free type 2. But again, it ended up being my problem, but like, there's no way to know until the data I generated entered their realm. Then it blows up, and then you have to figure out how to backtrack what went wrong. Okay. I think we're going back into GIMP. And we're going to make a new star animation. That one turned out pretty good. Start with a little blob. I think we'll just make a little blob. That's it. 4, 5, 6. We should probably make one that like pulses. 7, 8. This one might do it actually. 9, 10. Just by nature of the way the grunge works. 11. Oh, where are we at here? 1, 2, 3, 4, 5, 6, 7, 8. Maybe we do that. Nine. Eight. Let's actually erase this one. 8. 7. 6. 5. 4. 3. 2. Okay. There's another sprite animation. I think we'll do a small one. Then we'll ramp it up faster. We'll go like 5. 8. 11. 9. 10. 11. 8. 10. 8. 9. 12. Something big. And then 9. 7. 9. 7. 5. 2. All right, so that gives us three different stars, different behaviors. Stars are way easier to animate than people walking and shooting. Okay, we need images. Oh, I need to export that as well. So I'll hide the black background. Export to PNG. Okay. So we shall put Robert back down. These are like the top 3 things we need. So I like keeping those there. So Twinkle 2 starts at 36. Twinkle 3 starts at 42. Okay, we embed the new image data. There it is. And now, while that's building in, space init twinkles. This thing, sequence. Sequence key index, sequence index. Static cast to an integer, twinkle 1. Do we use twinkle 1 anywhere else in here? No. Static cast to an animation key. Our sequence index plus our index modulus 3. There we go. So assuming that finished, we need to bake in some new image warehouse. Shoot. Oh, it is rebuilding it, so that's okay. That may not be. Okay. Yeah, it's a feature I wish debuggers had. It was the ability to back up. And I know why they don't. Thinking about how you would implement it yourself, you'd basically have to, for every instruction, store an instruction that would undo the instruction before it's done. Basically, here's how you restore the previous state. So that could be register changes, memory changes, program counter changes, and a single instruction. Nowadays, we're not on RISC architectures anymore. That's not a thing. A single instruction can affect multiple registers and memory, and so for every one of those instructions, you'd have to have a mirrored undo operation that restores all of the previous state, and not just, probably not one instruction. It would probably be 3 or 4 or 5 instructions. It'd be like, here's each register that needs to be reset. Here's each memory address that needs to be reset to undo the previous one instruction. I don't think most instructions have a way to undo. Like if a load, a store, and add, those are all simple. That's, single register types of operations, or single memory address types of operations. But modern computers do not run RISC architecture. So, but I think it would be cool if you could do that. If you could rewind your program, like even if you accept, like, I know this is going to murder my runtime because for every instruction I execute, I have to write 3 or 4 instructions that I may execute in reverse. but it would be so useful sometimes, so much faster, potentially. Okay. Oh, bugger. Huh. Well, some of those are a little bit strange. X, Y. 16 by 16. I followed all the rules. But I did get a library word lookup failure. Therefore, do I need to do a full clean again? I really don't like that. All right, full clean it is. Okay, so text works. So what if I define the font before? Okay. So I don't know enough about SFML, but in FreeTech 2, you have to initialize your font library, you have to load your font. Then you define your own vertex buffer and your own shader. And all FreeType 2 gave you was the glyph information and the glyph rendering. It was up to you to pass all that to the GPU and render it. So I don't know what levels of abstraction SFML has. Okay, it's taking me a little bit longer than 2 o'clock to finish this up, but that's okay. Kind of, while this is going, we might as well start drawing the next star, right? That build is going to go for a minute. Let's make another star. We'll make one explode. So it'll grow like this up to about here. It'll be very similar to that. So let's make one that explodes. 5, 8, 11. And now we basically want to draw pieces of it flying off in different directions. Or maybe as like a ring. Then we chop our alpha. Chop our alpha again. Little fragments breaking up. Actually, I kind of want it to grow slower. It's just isn't as long. 1, 2, 3, 4, 5, 6, 7. Like a secondary explosion in the center. Maybe not 4. And then it sort of blows up. Or 3, 2. Or we can have it collapse back down on itself. So boom, explosion, secondary explosion. That's not bad. But it only needs 3 frames short. It is 3 frames short. Maybe do one explode and collapse. Well, this is kind of an explode collapse. Well, instead of 16, it's a 13. Save. Export. Images. And for whatever reason, well, I don't think it hurts my feeling at all to have 3 blank frames at the end. We'll leave it at the same length as everything else. It's at 42, it moves up to 58. Yeah, that sound warehouse always takes forever. Okay. We're going to start this build cycle. We're going to go to base. There will be 4. Big file. That's good. Okay. Oh, we'll just rebuild one quick tidy build with the image being rebuilt. That shouldn't cause us any memory layout issues. In theory. So that'd be 4 stars. All right. Nebula. Crab Nebula. Nebula NGC 604 looks promising. High res TIFF, 13 megabytes. Seems a little excessive. The Stingray. So maybe we grab NGC 604, Stingray. Those two look like ones I can work with. Ooh, the Eskimo Nebula. Maybe. NGC 6822. Okay. I've got a few options lined up. All right. I think that build completed successfully. There shall go. So we should have 4-star animations. Oh. Do I really have to do a clean and build? I told them 16. That is some bizarre behavior here. 20, 36, 42, 58. Yep, 16 by 16. Mm. Let's go to GIMP while I think about this. Sometimes you see more with white than you do with black. Okay. So let's get this one in here. Crop. Just the layer. Layer only, yep. Chop. So we will call this one Nebula. Oh, darn it. Nebula NGC 604. All right, crop it. Color to alpha. I want black to alpha. Well. That's not very good, is it? Color 2 alpha. Give me an eyedropper. Huh. It's not going to make this easy on me, is it? I mean, I have to erase a lot anyways, but kind of wanted this to be a little easier than it is. Oh. Is this chunk turning to alpha? I don't want. I don't get it. I want the things that are black to go away. But it's getting rid of the things that are white. What? Huh. I mean, I can erase a lot around these outer edges, but that's not really working for me. Let's bring in another one. Let's do the stingray. Color 2 alpha. Okay, that's hideous. Oh man. Colored alpha works so well with white. Maybe we just have to paint our own nebula. Well, shoot. I'm actually shocked that that's the way that's going. That's too bad. All right. Then in that case, now what do I do? How big is my star field layer? It does get scaled up a little bit. Out of hot water. All right, boundary size 874, height 254. So if I just get a paintbrush with a high alpha and I just start painting with colors, pick a nice blue, make it big. Oops. New layer. Nebula 1. That sure doesn't feel like a 23% opacity. Whoa. Okay, maybe it does. I don't feel like doing nebula. I'm done. I don't want to do a nebula. Forget it. Too much work. Okay, so what is going on here? I said this sprite here starts at 1920. 1936. 52. Oh, is that my problem? That says 42. 52. I didn't add right. That's a problem. 1968. Alright, that probably fixes stuff. Alright, export to. That's done. That's done. New file. How do you have to debug? Okay. So that should fix those 4 sprites. We could set a velocity so that the stars move, but I don't really. Even if it's small, it would be annoying. Stars don't move relative to your field of view very much. Okay, we gotta start our top secret project here shortly. So we'll test this real quick. See if our work. I don't really feel like doing a nebula right now. Maybe we'll do one more star? I don't know. Guess we'll see how they look now that I've got the alignment correct. Okay. Alright, I'm just gonna watch the stars twinkle for a little bit. I actually want a higher proportion of the spiky one. We need like 5 spiky ones and then one of each of the other kind. Will look better. That's my opinion. Space. There's four sprites. I'm going to do one of each and then fill the remaining 4 with 0. Index is less than 4. Do this. Otherwise, don't add anything. So let's get more twinkly stars. A nebula. A nebula? I kind of do want a nebula. Yeah, more twinkle stars. There we go. We do need more room between Jupiter and Saturn, I think. Okay, but basically, there. I think. So let's fix up some of these things. This is our XY. Okay. Mercury. Up here. With a 2-minute period. (90-second), 60-second, 45-second, 30, 20, 10. The distance between Jupiter and Saturn is not high enough. (60 to 90) is about 20, then we went 30, 40, 50, 60, 70, then only 40 more for that one. I think about 10 more. 50, 80. So these are going to be some very slow rotations on the outside. We'll have to sit there a long time for Neptune to go all the way around. But that's probably more realistic anyways. Little Mercury's going round and round. Earth, Venus. I don't even know where Mars is. Where's Mars? Oh, there it is. Wow. Mars was behind Jupiter. So the time difference between Mars and Jupiter is not as high as I thought. Mars to Jupiter, 30 to 45. I think Mars 3, Venus 10, 20, 30, 20, 15, 25, 50. 90, 120. Jupiter really seems to be moving pretty fast. Okay. So slow things down a little bit there, give a little more room there. I do kind of want a nebula. Added some dynamic twinkly stars to the space chalk doodad. Nebula. Let's see, get status. Not seeing anything here that I don't want. Added twinkle stars. Okay. I want a nebula. So what if I do this? Where's my... Oh. We've already got this up. All right. So what if we bring back in Stingray? We move it somewhere. We crop it. What if we just... Layer, scale layer, 254. Okay, we're gonna move it here. And we'll make a new layer. Nebula Stingray. All right, paintbrush. Eyedropper. We'll grab a nice thing. Grass. We're just gonna fake some chalk marks here. Looks like parts of it are mostly this greenish color. So if we fill things in with green a bit. We sample a different color and we try to swirl. Yeah, no, I'm not really buying it. Let's see, maybe how to create a nebula. So there's always art tutorials, right? So they're saying make clouds, gradient, blend. Yeah, that might work. Maybe if we do a cloud gradient. Okay, we'll try that. We'll try it. All right. Delete. Delete. Okay. We're gonna go ahead and crop this bad boy to 254 by 254. Nebula 1. Might as well duplicate this guy, right? Nebula 2. Move the active layer. I don't know how many nebula we have room for. 3? Looks like we might have room for 3. 1, 2, oops, 1. Nebula 2. One, 2. Duplicate. Nebula 3. I guess we'll just make our own. 1, 2, 3. Nebulae. Okay. So what I hear is I go into render noise. They said Perlin noise. It's very square though. I don't like it. Iterations. Scale. Huh. Go to alpha. The white looks fine. Duplicate layer. Nebula 1 color. Select all. Bucket. Multiply. Fog. See? That's not that bad. Maybe we just go huge. Go for 249. Do that. So give us a nice green. This one, nebula color. Where's my bucket? Radiant. Go from like a blue green. I do not like that. Oh, what? I said, wow, okay. Oof. Remember that nice hideous green we had? To a blue. Swap. This, what is this? Foreground to background, HSV. Multiply. Um, oh, what about this? This one is normal, but this one above, I'm going to make this one the multiply. That's probably what I'm supposed to do, no? Oh, white paintbrush. So delete all that. Then do that. I said white. Oh, normal. Normal. Select everything, delete. Opacity all the way, because this is our multiply layer. There we go. Are you kidding me? All right, I'm going to select bucket fill. Black. Paste. Then we take our paintbrush, which is smoke, white, paste. There we go. Now this color looks a little better. And we want to make it somewhat transparent. Maybe we do a bit of erasing. Just like as a oh, okay, let's try that. Nebula 1, Nebula 1 color. Nebula nebula 2, duplicate nebula 2 color. So nebula 2 is our multiply layer. So we select everything, we delete, bucket fill black. Then we've already done smoke. Maybe we'll go back to grunge. We make it around 250. Maybe a little smaller. Oops. Wrong. On the color. Color, we're just going to bucket fill for now with a nice bright red. Nebula 2. Paintbrush. White. A couple of nice little splotches. Wow, come on. Paintbrush. How is this not? Oh, okay. White, white. Let's do gradient. We're gonna go foreground to background, red to yellow, radial. We could go linear. Let's go from here to here. No, it looks splotchy. I don't like it. Let's go with black again. For that stuff. This one's red. So our shape. Let's go with this. Let's do this. Layer, filters, render. Okay. Turbulence. Okay. Color. Now we get ourselves a gradient, foreground to background. Sure, yellow. And then what's bilinear do for me here? Not really a big fan of that one. color. Linear, square, spiral. That's odd. Huh. Actually, I think I want this. I just have to do all of these in radial. I was trying to go for something a little bit more interesting, but okay. Radial. All right, eraser, brush. This is the orange erase. Oops. All right, there are strange things happening because this layer. We're gonna do some color things here. Desaturation, saturation. Make that back to multiply. There's the yellow we were sort of expecting. Then we erase. Except what that does is the wrong thing round. That's no good. Alright, I don't like grunge. What's this one? Sponge? Maybe we sponge it a little bit. Interesting. No. What's this one? Texture. Very descriptive. I don't want to reuse smoke for everything. Maybe go with like this acrylic. In the color layer. Slightly purple paintbrush. Not acrylic. Let's go. We go back to smoke. And just add a little purple over the top. I don't really like this at all. So let's select everything, delete, delete. Oh. So I did like generating the plasma. And then making it grayscale. I think that was good. Eraser. Maybe this is what we need to do. Is erase around the thing. I think that's got the effect we're looking for here. Nope. Let's kind of chew away those edges. So maybe we go with vegetation. There we go, getting some edges. Yeah. Then blur. That. Then we can fill in the color. Gradient. Purple to yellow. Radial, I guess. Apply. No. Okay. Duplicate. Delete. Fill. Black. Merge down. Now this one is multiply. Okay. Okay. Back to gradient fill. Okay, there we go. Make it not very much there. Save. Okay. This one. We should get one more nebula. Oi. Oy, oy, oy. Duplicate. Color. This one. Select all. Fill with black. Hmm. Normal multiply. Okay, I actually wanted to erase here. Oops. Green to blue, radial here to there. Select all, delete, paintbrush. We did this one with cloud, made it 240-ish, 100% opacity. We made it white. Normal. Okay, so that looks normal. I agree. So when I multiply, this one to multiply. Oh, there we go. And this one gets alpha and an eraser where we were using, well, grunge, huh? Cut it in half. And then go bigger and less strong of an erase. Something like that. Maybe the 2 I'm fine with. So 3. Oh, we did this one backwards. So this one is normal, this one is multiply. Full opacity. This is the one that we want 50-ish. There we go. There we go. Okay. All right, now, nebula 3. Here we go. I guess we just decide on our color right away. On gradient, we can go like a nice red to yellow. sure. And these color ones are multiply. Multiply. This one. We could render noise, vegetation. What does that look like? Nope, do not like. All right. Acrylic splat. We can go back to the cloudy version. Smoke. I could swear. Red to yellow. Gradient. Drag the yellow in. Paintbrush. White. What's this one? Texture. Hose. Yeah, don't like that. Yeah, well, you know what though? Maybe this. Do this with some blur. Filters, blur. Multiply. That's not too bad. Do something like that. Whoa. Okay, we've got 3 nebulas. File. Export. Okay. Oh, this one. This one's still doing the thing. Shoot. Shoot. Because what did we use to do that? Okay. Oh, we gotta start over. What we did was we filter render. We rendered plasma. Okay. Then we took away the color. Then we erased it all around the outside edges. Opacity. There we go. Just gonna erase some sort of shape. Okay, then we're gonna erase some kind of noisy border. Cell. And maybe branch need bristles. Actually, let's get those bristles back. I kind of liked. Okay, and then we blur 5. Okay, maybe I don't like the bristles then. And of course it won't undo. There it is. Okay. I still feel like I need more texture through this thing. Actually, no, we don't. Filters, blur, Gaussian blur. Let's go to 3. Okay. So we put this all on a white background, black background. Okay. Save, export. We're going to hide twinkle star sprites. We're going to hide anything named color. And we're going to export the UVs. Background and doodads, etc., etc. Yes. All right. There. I think we've got 3 nebula. We can play with those later. Well, we're going to play with them now, but we've exported everything we need. Now, I think that means we're done with GIMP for the time being. We will need to come back one more time today, but UVs and images. There we go. We've got nebula 1, 2, and 3. Cool. Bed PNGs. Now, in space, have this star field. We also need texture quad m underscore nebula, which means we have one more object to add to the number of children. Star field m underscore nebula, this. Okay, and here's where we set our star field. Star field with m underscore nebula. Set texture. So not star field. Nebula 1. Static cast to image warehouse UVP. This thing static cast to an integer plus Matthew RNG next 0 to 3 not inclusive. Which of course should probably save somewhere. Nebula key. Nebula index. So we get nebula 1 plus 0, 1, or 2. We set our key. We set our UV equal to the nebula key. We get the size of the nebula key. Get our size, etc., etc. Set rectangle, thusly. Okay. So that's initialization of a nebula. Fade in. Update alpha m underscore nebula 0 alpha and here. Okay, so that's fade in, fade out. There is no update. There is a render, and we need to render the nebula on top of the star field. Okay, set bounds. So we've set the star field. Now we need to choose a location within the star field to put our nebula. Left, right. Maybe we rotate by 90. It also needs the clipping. Does it need the clipping? We should just always put it on the center line. M underscore nebula. That's move to no nebula needs a center line. W? That's unfortunate. I've been working on that this whole time? No. There we go. Nebula set center to width 2, height over 2. Set bounds. Move to m underscore star field rectangle dot height over 2. Put it on the center line. And then we want it on either side of the sun. The sun is placed somewhere. Sun rectangle. Need this anymore. For each object, move them somewhere. Okay. Blah, blah, blah. Set clipping entity this. Offset. Offset. So basically, the nebula needs to be this. So there's an m_sun dot left dot rect dot left. That's the left edge of the sun. Minus the nebula dot rectangle dot width over 2. So this is the rightmost place it could be if it's on that side. And over 2. Float x equals and we want the option to be on the left or the right. Float x if math RNG coin flip. We use that x, otherwise something similar, but not quite the same. Let's swap these because we want to go from the sun dot right plus half the nebulous width all the way over to r dot width minus that. Move to okay, what else is there? Load planet, not interesting. Update alpha. Let's just try it. Okay, so this is a tidy debug build. See how that goes. Maybe that will be nebula's close to done. So basically we choose if we're on the left or the right side of the sun, and then there's a range between where the nebula would touch the sun to where the nebula would touch the edge of the chalkboard, and it picks a range in between there, and that's where it puts it. It'll be centered. We could rotate it an arbitrary amount just to, you know, just to confuse. It would at least grant some variation, but 3 nebula is probably enough for now. Yeah, maybe we should do the rotate toe thing. The rotation pawn set. Well, let's wait for the build to finish and see if it even works before we do that. Yeah, random rotation, collect good. Alright, I'm gonna have to heat up some more water though. Oop, oh, my camera there. Alright, not too bad. Okay, building, and hopefully the nebula just shows up in a somewhat reasonable space. I don't want the nebula behind the sun. And I don't know if the alphas are going to be sufficient. Nebula 1. I don't remember. Nebula. Darn it. I have a typo. Okay, we did redeclare float. That's unfortunate. I go fix that? I think I have to go fix that. It's going to worry my ACD. Nebula. 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 There's the keyboard shortcuts that people choose. Not very intuitive to me. Nebula. Okay. All right, so to re-export this, I need to hide the sprites, the colors, save. Oh, we don't. Yes, we do. Export UVs. Let me put these back in. We export the PNG. I'm not doing anything you're missing here, just renaming things a little bit. UVs. Okay, well, we don't need the colors. It basically replaces everything down to the sprites. All right. Redo all that. Nebula. All right. There we go. In theory, I'll guess a random nebula on the screen. Then I'll heat up some water and we'll start the interactable piece. The interactable piece shouldn't be too bad, I think. That leaves next week for chalk doodads stop and start, so you can cycle through them. and a plant growing one. Is there even room on my doodads thing for plant growing? Yeah, maybe. Okay. It's there. And testing. If it ever finishes the build. Come on. There we go. I do not see any nebula. Oh, it's way up there. Okay. It does fade in and out, so that's perfect. Load it back up. That looks like the same one. It's 1 in 3, so, you know, one time in 9 pairs it'll happen. Okay. Alright, so we gotta move it down into the star field. Easy enough. Set center. Set bounds. Starfield rectangle dot y plus that. Actually, nil y. Then I think we just add a little rotation to the texture quad and call it good. Oh, maybe we change the alpha a little bit. Maybe we alpha them down to 50. The pixels are already partially alphaed. So there's our. There it is. That's not too bad. You can see the stars through it and the things. Load back in. Planets should all be on top. I'd like that to move around a bit. There's that orange splotch. So far they're all coming up on this side, which is possible. 50-50 flip, it's a 1 in 8. I would like some to show up over here though. Nope. Still over here. Problem with randomness, you can never predict it. Still over there. That's a lot of times to be on that side of the screen. There it is. Finally showed up on this side. That does happen sometimes. Randomness is not predictable. I think the orange one needs a little bit less alpha. But it is there. It is working. So where's my orange one? Nebula 3 color nebula. So Nebula 3. I'm gonna make it like 40% alpha. Alright, next time we export, we'll get that. We are coming up on that far side a lot more than I would expect, though. Which is, you know, randomness at work. We've only had one on the left. Right. Huh. Definitely showing up over on that side a lot. Not sure why. Coin flip should be roughly 50-50, because it basically goes through each bit in a random number selection. Is there something I'm doing wrong in my logic? If coin flip, we go from nebula rectangle half all the way up to the sun's left edge minus, let's see here, nebula width. Nebula radius. Just compute this once. Nebula radius to the left edge of the sun minus nebula radius. Otherwise, we go from the right edge of the sun all the way out to plus nebula radius. Nebula radius. R dot width. R is the full width. We just picked two ranges. Should not be that much different. Should be a 50-50. And if it's not, it's kind of whatever. It's not important. Just I would expect a little more 50-50 here. There it is on the right. On the right. We can move down a bit, actually. We can go... Why don't we do this? Y, float y equals a random number between this math, URNG, next float between that number and sun rectangle dot middle. Y. Can't go lower than where the sun is. The other thing we want is clipping. Just in case, right? Nebula set clipping entity, blah, blah, blah. Do that, and rectangle dot height. Maybe we just go from 0 all the way to the left. Since we're enabled clipping, we don't have to do the nebula radius, right? It's okay if things clip. It actually makes it look a little bit better, I think, sometimes to have some things clipping. We may even make some of the planets widen out their radius a little bit. Encomium. Okay. Like I think some of these outer planets could be deeper, wider in their ellipse by a bit. Oof. Okay. That does allow a little bit of overlap with the sun. So maybe we need to put that radius back in for that, just to keep it away from the sun. I don't mind if it's over the edges, but I don't want it behind the sun. Let's give ourselves a little bit more room around that sun. Nebula rad equals nebula.rectangle.width over 2. So we go from there to the left edge minus nebula rad plus nebula rad. Okay. I think we're there. I think we're done with nebulas. Still leaves me 2 hours to do the fun interactable bit. Okay, things are in place. I might make some of these planets even slower. Yeah. Ooh, let's see here. You know. So those are all out. O, N have to be in. I is out. R must be in, therefore no H. E, flogs. Jacks. Wax. Okay, there it is. It's F, G, or W, or X. So maybe like something like grow. So it's G and W. Roan. Wrong. As in, we've been wrong. Exit, fade out, done. Okay, we're following good. Nebulas are done. Journal. Nebula. Added 3 nebula textures. Spawn 1 random nebula each time game starts. No, not done. Not done. We forgot one thing. Okay. When we initialize our nebula. Here. Nebula dot rotate 2. Actually, let's do it after replace it. Set bounds. Move it. We'll rotate it to math urng next float, which is between 0 and math I times 2. Easy test. Oh, then I gotta heat up some water and shut the window. It's getting cold in this here office. Since I can't have the fan on, I leave the window open, but it's getting cold enough in the evenings that I can't really keep doing it. Okay, so there should be some rotation now. Yeah, sure. That's a slightly different angle. It's that diagonal through the middle is a little bit more horizontal now. I don't. This is a little bit busy around the letters, but we'll be able to dispel the chalk things eventually. Okay. We're good. We're good. We're good. So we're good there. Okay. Added nebulae. Boom. Done. Okay. I'm going to heat up water. And then we'll start on my top secret thing that I have not disclosed yet. Be right back. Okay. I wasn't going to grab cinnamon roll, but I did. My kids ate parts of cinnamon rolls and left fragments lying about, so somebody's got to clean them up, right? All right. Okay, we're doing good here. We're doing really good here. Now we're going to make a special interactable for space. And it is... I'm going to... Yeah, that looks stupid. Oh, no. All right, we are going to make a spaceship that you can fly. So I need to decide what it's going to look like. I was thinking like a Buck Rogers. Like they have some famous spaceships. Like we're not doing the Enterprise. We've got Star Wars style Bird of Prey from Star Trek. That's not Millennium Falcon classic X-wing. What do we want to do? Do I want to design my own, or do I want it to be an homage? Oh, we could do Serenity. We could do like a really cheap, easy one. That's just like a rocket. Hmm. Hmm. We need a spaceship design. I could ask an AI to design a spaceship for me, and then I could draw over the outlines. There's no way they would do it in the way I want. Do you want to copy somebody else's design? Oh, we could do the Cowboy Bebop. Cowboy Bebop? That's a fine ship. Where is it? Where is it? Wow. Okay, there it is. Swordfish. Should we do Cowboy Bebop ship? Anybody have any strong opinions? Let's see. Do I do Cowboy Bebop? Yeah, maybe we do. Open link in new tab. So let me grab it. Oh, that's not what I wanted. Okay, let's go to GIMP. Paste. Is there a new image anywhere? There it is. two new layer. We're going to move this bad boy. We want to rotate that ship. Is it going to fit anywhere? It'll fit right there, right? It's all the same size as the, okay. So, layer. I want the heading 0 to be that way. Transform arbitrary rotation. We want the pivot point to be right about there. That would be about where it would pivot, maybe between the wings. So down more. I probably shouldn't use the Cowboy Bebop, the swordfish. Oh, probably shouldn't. I don't have permissions. It's not a blah, 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 blah. Okay. Fine. We'll come over here. New layer. Nubla. Pretty sure I got rid of all the Nublas. Okay. Airplane. Rocket. Okay, we will crop it down to something. I'm not sure it really matters what. Doesn't need to be super big. 160 by 160. One thing we need to know is it is going to end up being longer than it is wide. Actually, it should probably be about the size of Mars, maybe? I don't really want a very big spaceship. Rocket ship. So how big was that? 57 pixels? Yeah, we probably should make it smaller. $43. Let's go for 3264. I think we'll make that our rocket. Okay. Paintbrush. Back to our good old standard grunge. 8 pixels. Do I just have two images? Okay. Go a little lighter. Go back to the darker one. And we'll go for darker. And then maybe something in between. Just to get a bit of a blend in there. A little bit narrower. Here we go. Just darken that up a little bit. Not that gray, this gray. Maybe we just erase some of the fin. Just to sharpen up that line a little bit. Feel like copy paste. Up here, layer, flip. Actually, maybe what we do, let's delete that. Go back to the eraser. We're going to trim the nose just a little bit more. Cut the ship in half. Select invert, delete, paste, layer, transform, flip vertically. We get a little bit more symmetry in. To new layer. Merge down. Okay. Paintbrush. We're going back to that dark one. This one. 2. We just want a bit of a radius. There. Do a little window here. Oof. We just want a little shine on there. Anything else we want here? Save rocket. Duplicate layer. Rocket on. Rocket off. Okay. Remove rocket on somewhere else. We're gonna go get some white. Let's see, let's duplicate this layer. Delete. Okay. Yellow. Orange. Red. There's the yellow. Shoot. Just a little bit on the short side. Maybe we need to let's look at the star. Start with yellow. going to put a little yellow. Orange. A little orange. A little red. Okay, back to the orange. Good enough. Save. All right, rocket on, rocket. Merge down. Rocket on and rocket. Okay. We turn off the twinkle star sprites. We turn off the nebula colors. Save. Export. Not that. Cancel. Cancel. Come on. Come on. Let me cancel. Oh, whatever. We'll redo that in a second. This is the one we meant to click. Okay. Then we turn the colors back on and the twinkle star. And we export that PNG. There we go. Okay. Rocket. So we go to... Hey, I'm alive now. Nice. Do you want to know my top 4 tracks this month on Spotify? Sure, shoot. I don't listen to music while I'm streaming, but I usually listen to music when I'm working. Otherwise. So UVs should have rocket on and rocket off, which it does. We're going to go to journal UVs, images. Delete all of that. Source builds debug word sleuth. No, we go to this part. Okay. And now le bon franquet Louis Herbert in Berne la manifestation. Interesting. I don't recognize any of those, but then again, I don't speak French, so I guess that would be why. Are they any good? I keep meaning to learn Irish, but I haven't made the time. I speak Spanish, so I can understand a decent portion of written French, considering that I've never studied it. That's what you get with Romance languages. A lot of cognates and similar grammatical structures. Okay. Okay. Space. We're going to add text quad underscore rocket. We're just going to make sure it shows up in the right area. Number of children plus 3. We have the star field, we have the nebula, and the rocket They're all managed differently. So doodad chalk space. Let's see. From 2nd to 8th grade is made by the same author. The 2nd and 8th are made by the same author. Okay. By the way, just speaking English can make you understand French easily written. Yeah. There's a lot of French words infused in English. That's true. I noticed that when I was going through the words for my game, I had to decide which French words I thought were English enough and which ones were basically if it had an accent mark. I didn't keep it because you can't type those in this game. But yeah, English borrowed a lot from everything, so people often are surprised. Like, oh, that's a Germanic word. Oh, that's a Romance language word. That's a an Irish word. In fact, there are Irish words that are still in use today in English, but nobody notices it. Warden came from French. Cool. No, languages are fascinating. But I feel like I've already got my Romance language in Spanish, so I'm not really interested in learning, Italian, Portuguese, French. Like maybe Romanian, that's technically a Romance language, but it's like so far down the language family tree. It borrowed a whole bunch from, what was it, Hungary? Something, I don't remember. So it's like the most different of the Romance languages, but I think I need to learn something else. I'm going to go for Irish and Russian, I think. Then I don't know. Maybe we'll do Greek or Hebrew or... I'm not really interested in Oriental languages right now. They're further down my list, so... But like I said, just haven't made the time for them. Okay, now we're going to get the width and the height and scale it and center it. I think that manifestation was quite easy to understand. Yep. Well, the bon franquette was is that? I'm just a guess. Is it the good little French girl? Maybe. Yeah, la manifestation makes sense. But from all the songs that I have, I think the easiest to understand for an English speaker is Louis Herbert. I don't know how to pronounce that because it has a quite basic language. There's a lot of words that are very similar to English. There are some parts that are 100% English. Okay. No, yeah. So like when I was learning Spanish, I did like listening to music. I think it's a great way to learn language because you can listen to it over and over again, so you can hear it, the same phrases, the same pronunciation over and over again. And you can look up the words, and then you can sing with it. So that helps your pronunciation, right? Because you're then imitating someone else's voice. I think music is great, but I tried to pick earlier songs that were easy to understand, where it was slow, the person spoke clearly. Like a lot of modern music is not very easy to understand for a non-speaker. So you gotta work your way up to those. Okay, OBS. I have a song that's half French and half gibberish. Nice. We're going to put this guy at 0, 0 width and height. We're basically doing this for the rocket. Okay, so that's part one. Fade in, update the alpha on the rocket. Let's just get it to show up here. Update. Update the rocket. We'll get around to that here in a second. Render. We want the rocket to appear on top of everything, including the sun, but behind everything that's in front of the sun. So, this is the one place where it's going to get interesting. If objects at this index quad is equal to the address of m_sun, then we draw the rocket. So that's kind of fun. A little different for us. That automatically takes care of all the layer stuff. Here's the thing. I think that we have a reverse effect for comprehension for non-native speakers. Oh, really? Because one of the authors, if you look at their songs in the 2000s versus in the 2020s, there's a major difference. 2000s are often more fast-paced. 2020s has a slower pace. Huh. Interesting. I haven't really compared song lengths. I mean, I know that there were some very long songs in the 80s, and I mean, you have your The Doors, Moody Blues. A lot of them had very long songs, those old rock ballads. Yeah, I guess most songs these days are pretty short. Maybe that's true. Okay, rocket's gonna be put somewhere. Update alpha, update the body, sort bodies in twinkles. Update rocket. Okay, that's what it's called. Here's the issue with those songs. Okay. 99% of them are all political. Politics. I didn't want politics in all my life. It'd be nice if politics didn't have to be such a big part of everybody's life. See, when I was learning Spanish, it was all basically love songs, so not many political. Actually, that's not true. There was a couple of political ones. Like Juanes, he was writing about the things happening in Colombia. At least for his first album. His second album was more like love songs and such, but now we're not going to do anything with the rocket other than draw it once. That'd be good. Okay. So we can get the rocket show. They say the issues and the solutions. They also actually do something. They have an organization that for every ticket for their shows, they will pay land in South America to save forests. One, those are often already not the best efficient, most not very good uses of money. A lot of that money goes into in those kinds of save the whatever. They're often quite grifted, where people are skimming a certain amount of money every single time through hands, so that the actual number of trees saved is very minimal. Or or whatever. They're all very similar organizations. Two, there did used to be a big worry about we'd run out of trees. That since has changed. We're actually got more forested in the last 30, 40 years than we were back in the 1800s. Originally, they thought they were going to run out of trees was because everything was wood fired. Until we discovered coal, we actually saved the forest basically because of charcoal. And then when we were about to have big problems with charcoal, guess what? We found gasoline, and then and petroleum. And after that, we discovered natural gas. Like every time you think you're just about to run out of something, humankind finds a way to keep going. Oh yeah. Akshay 110? Oh, nope, just 10 Lange. Welcome to the stream of the Discourager of Hesitancy. We are building a game with no game engine. How's it going? Thank you for the follow. The singers are the rare ones in Quebec that went international, yeah, because they did shows in France, Belgium, and Switzerland. Okay. Right, let's run this and see if the rocket shows up at or anywhere near where it should be. There's our rocket. That is not sized correctly. Yeah, I don't like that. Well, shoot. It shows up. Our rocket is width, height. 6433. Width, height. Oh. This is the problem here. That will size it better. Oh, try that again. But the one that actually went international, you probably even know one of her songs. Even on Prime Video, there's a biography. When it's international, it's no longer just French-speaking countries. Okay. Well, who was it? Or what was the song? Or both? I don't know if I listened to enough music to have caught it. There's our rocket. All right. Okay, cool. Oh, Celine Dion. Yeah, yep, I have heard the name and I do know the movie. Never watched it, but that sure was annoying. It was always on the radio. I think Celine Dion has a very high opinion of herself. Yep. That's the one. She's a good singer, but I think her ego was more than her talent. I like a little humility in people. Okay. Now, rocket. If input is key pressed, Are you responding to the robots? I'll just say that I did want to use the more rude way of saying it. If you know, you know. Oh yeah, for sure. Input key. I think we'll use spacebar here. Space. And all we're gonna do is m_rocket on. Else if is key released. Oh, come on. Input. Is key released. Space. I'm gonna go to off. Let's just start small and simple. Input has not been declared. Okay. Let's go get input then. DT is not used yet, but it will be. We will have a rotational velocity and a velocity. We'll have thrust and a maximum velocity, probably. Otherwise it gets a little silly. Okay, spacebar. Oh, how cute. All right, let's go put in rotational velocity. Okay. Float. Rocket rotational velocity. Zero. And we're basically gonna steal this piece. M_rocket dot rotate to rocket dot angle plus M_rocket rotational velocity times dt. Is keyed down. Left is key down. Input key right. Then we have to get a rotation. So if it's left, we need another number. We need load_rocket rotational acceleration I need a max rotational velocity. Renderer scale 2 pi. You can rotate once per second maximum. 4 twice per second. We want to accelerate. Actually, this does not need to scale, does it? These don't need to scale at all. Our velocity will, but not our rotation. What? 15 degrees math. Deg 2 radians. Degrees to radians. 15. Okay. Okay, if left, then rocket rotational velocity plus equals our rotational acceleration times delta time. Left is a positive sweep. Square rocket rotational acceleration is greater than this number. Then we just click. If it's less than the negative of that, we clamp it there. Right. You can simplify this a bit. Right. This is plus. So it can only get bigger. This one is minus, so it can only get smaller. We update our rotation. Okay. All right, let's do a rebuild. Well, I hate the fact that my nation was pretty much the most conservative nation pretty much until 1960. So what happened in the 60s? The religion basically ruled everything. I can't change anything about it. Yeah. I mean, you can vote in your elections, talk to your friends, but yeah, there's not much. A lot of culture has gotten very weird. I still can't believe Canada has the MAID program. Like, I don't know. There's a lot of very bizarre things happening in Canada, and I don't know why it hasn't stopped. Why nobody's? How can the percentage of people who disagree with what's happening has to be big enough to cause some change, but it doesn't seem to be happening. The people that think that the way the MAID program has gone was unpredictable has never, ever, ever, ever read a history book. We all knew as soon as it happened. Okay. So we're left arrow, a right arrow, left arrow. Okay, so 15 is too small. Yeah, 15 is too slow. We need it to rotate faster. Still, not bad, not bad. So 15, way too small. We should just give it a full pi x. Just give it a pi. You know what? Let's give it 2 pi. Move to x. Oh, not that y. I want m_sun rectangle dot x. There we go. Not y. All right, let's get this rotation done. Canada is not united. There's a major split. Yeah, I know. I've heard enough Canadian commentators disagreeing, and then the other side obviously doing their thing. Cities in Quebec has way more influence from Europe than the rest of Canada. Yep. Which I think is a thing I've heard all other Canadians saying. Basically, Quebec is mini France, but yeah, I found the source of the segfault. Fault. Good. The GUI log was correct, but the implementation in the scene was really badly managed. So their example code was risky, but it was okay since they were in a very controlled environment. But as soon as you try doing anything interesting, you have to be a little bit more careful with that. That kind of the thing. Okay, there's a rotation. I feel like it's not clamping my maximum velocity here. If twice per second should not be that fast. So it should really only take 2 to 4 seconds to go from a standstill to fully rotating. One, two, 1, 2. And that's more than 2 rotations per second. 2. This is about 1 second. That's closer to 2 seconds. I think I want front arrow for the flame on. So is it not clamping my rotational velocity? It feels like it's not clamping. because SFML decides to not duplicate the font object, which makes everything 10 times harder. Yeah, so you have to maintain a reference and keep track of who owns it and who doesn't. I have an idea. Wait, quick question. And herb or a herb or an herb? I would say an herb myself, but I don't pronounce the H in herb. Okay. I don't think it's clamping my rotational velocity. I don't want to clamp out here. Shouldn't have to. I looked at it and it said both are correct. There's one dude who keeps arguing that I'm wrong. Because if you pronounce the H in a herb, it is correct. Yeah, if you say an herb, you don't pronounce the H. Yep. I don't pronounce the H in herb. That's probably because other languages that have that cognate with herb, they usually have, like, so in Spanish it's yerba. It's a Y. So I don't pronounce the H. All right, Rocket. It is not clamping the rotational velocity. Oh. Because we're clamping the acceleration, which has nothing to do with the velocity at all. Perfect. Okay. We can move this back in. We have a typo, and all is better now. Yeah, if somebody said a herb, I wouldn't say anything about it. Okay. Now we should be clamped to 1, 2. Yep. That's about half a rotation per second. Very good. So now we can make that larger. If we make that 4. Should only take us about 2 seconds to get up to speed. So 1, 2. And that's as fast as it should go. That is still kind of a fast rotation for a rocket. Maybe just go to 1 second. One revolution per second. Okay, that's besides the point, because now we're going to add rocket velocity x and y m underscore rocket acceleration rocket max velocity. Start at 0. Our maximum velocity I don't know. Acceleration? No idea. Again, we'll kind of find out how that all goes. Okay, if. So this is all rotation, this is all linear. Okay. Yeah, he's the kind of complain about every part of my English, but that's just what a lot of people who learned English do. Yep, bilinguals that learned English are often the worst. No offense. Yeah, yep. Sometimes. So our rocket has an angle now. And if rocket dot v key is equal to rocket on so let's not start by velocity x plus equals the cosine of rocket angle times delta t times underscore rocket cell. Okay, so we're going to change our velocities. Then regardless, I'm underscore rocket dot move by rocket velocity x times delta t underscore rocket velocity y times delta t. So we're not clamping it. We'll have to clamp here at velocity. Okay. Yeah, unfortunately, when you learn a foreign language, you start to learn different areas to pronounce things differently. So when I was, you speak English, sure, but is it like British English or like Southern United States or Pacific Northwest or East Coast, Central? They all have different ways of saying things. Same thing with Spanish. Is it South American Spanish? Is it Spain Spanish? The swear words are different between languages, between countries. I imagine it's the same with French, right? You have your France French. You have your Quebecois. Really forgot that semicolon. And so when people are being overly corrective, it's often doesn't matter too much. My English is a mess. I mix a lot of dialects. Yep. Same thing with my Spanish. Like I spoke with people from Guatemala, Colombia, Puerto Rico, Dominican Republic, Spain, Chile, Peru, Cuba. Like I spoke to a ton of people from all over, and so I never really got stuck in one dialect. Of course, I also haven't spoken Spanish in a long time, so not to anyone real. So it's probably a little rusty anyways, but yeah, even when I spoke it quite a bit. Okay, so first of all, there's our thrust. Rotate. Oh, whoa, whoa. Oh, oops. We went off screen. We'll have to fix that. I knew that was coming, but... Okay, so we're going to rotate a little bit. Okay, it's not right. Because of the y-axis. I get it. All we have to do is change this to a minus sign. I mix up next. I fixed it in a lazy way. Okay. Fixing your seg fault. Okay, so a little bit of a rotation going. We have a flying rocket. It's not stay on the screen, but we have a plan for that. It's amusing. Okay. We are not clamping our velocity either. So what we need to do is math. Give me the magnitude. That's awkward. All right, magnitude of rocket velocity x, rocket velocity y. How fast is 400 pixels per second? our velocity magnitude is this if our velocity magnitude is greater than underscore rocket max velocity. Then we have to clamp it. So we say where's math? Mag normalize underscore rocket velocity x rocket velocity y, which we don't have to pass this in. So what this is rocket velocity x divided by velocity magnitude and times our maximum velocity. So all we really have to do then is times equals that. Okay. Now, one last piece. We are going to do one last piece, and I probably ought to call it good there. The rocket flies off the chalkboard right now, and that's not the worst, but yeah, underscore is here. X equals underscore rocket rectangle dot x. Actually, it's fine. Float y, float radius will be the rocket width divided by 2 if x is less than negative radius, then x equals rectangle dot width plus the radius. If x is greater than rectangle dot width plus our radius, then x equals minus radius. Then basically the same thing for y. H. Then we move to x, y. Okay. Let's try it. Magnitude. Oh, is it just mag? Okay. Oh, goodness. Let's try this. Let's fly our rocket straight ahead and see if it wraps around. It does. Woohoo! Does it wrap on the vertical? It does. How fast is our rocket? Little squirrely, not too bad. I've seen worse. Whee! There we go. We now have a rocket in our space. Oh, man, it's squirrely. Oh, okay, maybe our maximum acceleration, maximum rotational is too high. Whee! I think I want arrow key instead of space. So up, up. Okay. 2, I think my maximum rotational velocity a little bit much. All right. I think that's going to be it for the rocket, which means we're probably about done for the day. It's a little bit early, but I know I have to go around and do things here shortly. So let's just make sure that feels okay using the arrow keys. Okay, that feels less weird. Okay, cool, cool. One other thing we want to do, or two. Maximum velocity, rocket velocity X. Math, you are in G. Next, float. We don't want it fast. Maybe like 15 or plus or minus. So if you are in G, coin flip. Rocket velocity X equals minus underscore rocket velocity X. Velocity Y can be 0. I do want to set a random rotational velocity as well. Rocket rotational velocity equals math URNG. Next, float. Actually, what am I saying? Let me just go minus 15 to 50. Rotational velocity between pi over 4 and pi over 4. We'll just start off the rocket in a tumble along a horizontal line. Okay, when we load in, our rocket is in a slow tumble. It's above Neptune, but behind Saturn. Yep, that's fine. And that's it. Charge. Whee. That's not half bad. Okay, we're done. We're done. Rocket ships and orbitals. We feel smarter already just for being here. Nebula. Stars. Slow drift everything. Cool. We're done. Yay. Done, done, and done. Special interactable, spaceship that flies. Spaceship now flies with arrow keys and sweet. Added spaceship and it flies. I would not mind adding a sound to it. I don't know what sound I would add. Do I have? Let's just add it to our to-do list. Space doodad. Here we are. This one right here. Space doodad. Sound for rocket engaged. Yeah, like teeny tiny little things. This is not like code worthy really to speak of. Yeah. That's basically it. We're done. We're done. Journal. Done. Done. Okay. Good work. So tomorrow is compiler day, where we are going to build our compiler on top of our own tokenizer generator. Well, we're building our tokenizer generator on top of our own generated tokenizer from our tokenizer generator. So it's going to be great. So see you then. Have a wonderful evening. I will see you all tomorrow. Have a good one. Bye-bye.